Hello learners, today is lecture number 4 in the subject Design of Concrete Structures and Unit 1 Properties of Concrete. So in today's lecture, we will be able to understand that what is working stress method of design of RCC structures and limit states of limit state method of design. So these two methods we will be discussing today. As in the lecture number 3, you remember we have gone through and we have discussed what are the objective of design of RCC structure. So we have discussed some basic requirements, that means a structure should be stable, having sufficient strength, as well as it should be having satisfactory performance during the uses. That means when that structure is used by the occupants or the purpose for which it was built, so it should perform all the functions comfortably. And the two methods we have discussed, that one is limit state method of design, which is currently in practice, and earlier there was working stress method, which even we can use wherever limit state design method cannot be adopted conveniently. Then we have discussed that IS 456 we will be referring in case of plain and RCC structure, reinforced concrete structure. So this code of practice will help us about the guidelines which we have to follow and to make a structure safe and sound. Then how the loading calculations can be done, that means how the load values can be assumed to work out the stresses as well as the design of the RCC structure. Now today in this lecture, let us discuss what is the working stress method of design of reinforced cement concrete structures. So first of all, we have to understand the philosophy of the design by this method, working stress method. So let us understand it more clearly. In this method, it is assumed that the structural material, in our case structural material will be concrete, that the structural material behaves in a linearly elastic manner and that adequate safety can easily be achieved by restricting the stresses in the material. That means when the material will be having, suppose we are talking about the steel, then steel has yield stress. Similarly, the material, other material which is in practice, that is concrete. So concrete has some compressive strength, which we have gone into detail in the earlier lectures. So what we have to do, we have to restrict the stresses, or you can say we will be taking some reduced value of the stress, so that whatever be the expected loads will be subjected to the structure, which are known as service loads. So it is assumed that the structural material behave in a linearly elastic manner. This is our assumption in working stress method, and we are restricting the stresses so that whatever be the load on the structures are coming, they will not fail the structure basically. Now these specific, after restricting the stresses, we will say that we will be obtaining the value of permissible value of the stresses. That means whatever be the value of the stress, which we term it as allowable stress, are kept well below the material strength and within the elastic limit. So whatever be the material strength, and accordingly we will be allowing only permissible stresses. For example, if we say concrete is of M20 grade of concrete, for example, so 20 MPa will be the strength of the concrete in compression. And as per this methodology, we will be just reducing that strength for our calculation. Let us take uh, the concrete of strength, suppose it is 20 MPa, and we can take it allowable only 10. So that means 20 MPa strength of concrete, that means concrete of 20 MPa strength will be just assumed as having a 10 MPa strength. So for this 10 will be our allowable permissible stress and 20 will be the actual strength. So what we have to decide, we have to take care that whatever be the stresses coming on the structural element, that should be well below the material strength. The stresses under applied loads will be analyzed by applying simple bending theory, which we have already gone through in strength of material. Everybody is well aware about the simple bending theory. Now it is also assumed here that steel reinforcement and concrete, they both act together and are perfectly elastic at all the stages. So here this assumption leads to the observation that steel and concrete will be acting as a composite material and they will behave as a perfectly elastic. This is the assumption in the method of working stress method. Now fourth one is next one is stresses in concrete and steel are assumed to be linearly related to their strain. So that means it is also assumed that the stress strain relationship for the material is a linear relation. So that means stress in steel is linearly related to that in the adjoining concrete. So that means when you embed the steel in the concrete and when it get hardened and subjected to some loads, and due to that load some stresses will be developing, and here it is assumed that stress in steel is linearly related to the concrete in which it is embedded, and then we will be using a factor of safety. uh, Later on we will use factor safety. So this relationship will be known as modular ratio and it is written as M, symbol will be M. So compressive stresses by concrete and tensile stresses by steel, this is the another assumption that all the compressive stresses will be taken care by concrete and all the tensile stresses will be taken by steel. However, we know that steel can also take some compressive stresses, but here in this method we will be assuming that whatever be the compressive stresses on the member, they will be taken care by concrete, and whatever be the tensile stresses, they will be completely taken by steel. Now let us discuss modular ratio. Modular ratio is basically the ratio between modulus of elasticity of steel and concrete. That means it is a ratio which will be just giving the relationship between modulus of elasticity of steel and concrete, and it can be used to determine the stresses in steel and concrete. Now here other important assumption is we will be assuming that there is strain compatibility will be in the member. That means strain will be equal in both the materials. Now ratio of material strength, as we discussed, to the permissible stress will be termed as factor of safety. Now we can understand it that permissible stresses will be yield stress, which is the material stress, divided by factor of safety. So for example, if you are taking a steel of a grade maybe Fe 250, so then its yield stress will be 250 MPa, but you will be dividing it some factor of safety. It may be taken as 3. So permissible stresses will be 250 by 3. So it means the steel which is we are using in this concrete in RCC member, we are just considering the yield strength of steel now when it is embedded in concrete is one third of its actual strength. So that will be the permissible strength. So another point is the stresses caused by these service loads. So whatever be the stresses coming on the material due to the service loads, that means the loads which are coming on the structure, they will be checked against the permissible stresses. So this line indicates that whatever be the stresses coming on the material, so that stresses must be less than the permissible stresses. Permissible stresses is the highest limit which we can allow in case of working stress method. Now let us discuss few limitations of working stress method. Very first limitation is we are assuming in working stress method that concrete is a elastic material. But in actual practice, in lecture 1, 2, 3 we have discussed, in actual practice concrete is not elastic material. It is basically possessing inelasticity, so it is inelastic material. So that means this is the drawback of the or a limitation of this working stress method. Now second important limitation is factor of safety which we are taking, that it will be taken only for stresses. That means we are not taking into consideration loads. Factor of safety is not taken for loads, it is only taken for stresses. That means it will not give the real information about the actual strength. Third limitation is in the working stress method we don't discuss anything about the shrinkage and creep. So far we have discussed the working stress method, and working stress method not clearly indicate that what are the provisions we have taken for concrete when it is subjected to loading and shrinkage and creep stresses will develop. And we have discussed that shrinkage and creep stresses are also time dependent and plastic in nature. So here working stress method is silent about the stresses which may develop due to shrinkage and creep. Another important point is this working stress method will give uneconomical section. Why it is uneconomical? Because we are using higher factor of safety. Factor of safety for concrete will be taken as 3 and for steel it is taken as 1.8. So why we have taken 3 for concrete and 1.8 for steel? That you may have studied in strength of material also, that concrete is man-made material, that it will be prepared at site. So we are not sure about the quality parameters which will be adopted at the site. Also we have discussed in the previous lecture that concrete is supposed to be a composite material, and we are not sure about every ingredient of the concrete which will be having same quality, but still we can manufacture in the factory. So in factory we can control all the conditions, that means quality control parameters are more stringent in case of factory made products. So that's why we have taken lesser factor of safety in case of steel and a higher factor of safety in case of concrete. So here you can easily understand that by applying a factor of safety of 3, we are actually reducing the strength of concrete by one third when we have to do the calculations. So actually if suppose M30 grade of concrete is there, then strength of concrete will be 30 MPa, but by dividing its factor of safety by 3, we are just considering the concrete of 30 MPa is having strength only 10 MPa. So that's why we have to use more quantity of concrete as well as more quantity of steel. So due to that, it will be giving us an uneconomical section. Fifth point is there will be no information about the behavior of structure during service life. That means when the structure will be subjected to actual loading, that means when people will be start occupying that structure and some live loads will be acting on it, and how it will behave after the construction, and what type of parameters, like whether there will be any leakage, etc., cracks, etc., and permeability, durability. So all these information are not available in working stress method, because working stress method is mainly focusing on the strength of the structural element, but not about the behavior of the structural element after when it is in practice. So IS 456 recommend now that is limit state design method for RCC structure, and you may use working stress method in the design, but then you have to face all these limitations, and you have to compromise on some of the properties of the structure as well as the economy. Now let us discuss what is limit state method of design of RCC structure. So first of all, we have to understand what is the philosophy behind limit state method of design. Now you can see here the name of this method is limit states. So limit states mean you are talking about some states or positions where you are limiting some information. That means something is limited here. So as the name limit state is used in limit state method instead of failure. Here we are not using failure word, but we are using the limits word. Now we can understand it more effectively. The limit state method use multiple safety factors which attempt to provide adequate safety at ultimate loads as well as adequate serviceability at service loads. So earlier in working stress method we were concerned about only adequate safety, but here in a limit state method we are using additional safety measure, that is adequate serviceability at service load, by considering all possible limit states. So that means here we are again talking about that limit state method is linked to limit states. So what are the limit states? What type of limits we are imposing in case of limit state method? Let us go through. The selection of various multiple safety factors. Here we are using multiple safety factor. So how to select the multiple safety factor? What will be the value of the safety factor? Later on we will be terming them not as only safety factor, they will be partial safety factor, is based on the sound probabilistic analysis. That means it is based on the values will be worked out on probability analysis by considering different kind of failures. So here we are talking about different type of failures, different type of material, and different type of loads. So based on all these things, that means type of failure, type of the material, and type of the loads, we will be selecting the safety factor. So in working stress method, we were not talking about the type of the loads. There was no safety factor or factor of safety, we can say, for loads. So what is limit state? Limit state is a state of approaching failure. So that means we are not getting the structure here failed. So failure word is removed, but we will be saying that it is the state, limited state, when the structure is just approaching the failure. Structure is not getting failed, beyond which a structure ceases to perform its intended function satisfactorily. So what we are saying, that we will be adopting or providing or limiting something in the design, some parameter in the design, such that any structure, when it will reach beyond that particular state, limit state, we will say now structure is not performing its function satisfactorily. In terms of either safety, you can say now structure is not safe. Maybe structure has not fallen or has not collapsed, but we will be saying that beyond this limit, this structure is neither safe nor serviceable. That means you can't use that structure. It may either collapse or become unserviceable. So what is the possibility? Possibility is that whatever the limit we are imposing, beyond that limit may be some particular stress, either the structure will collapse or structure will be unserviceable. That means you can't take the services of that particular structure. Now, regarding limit state method, you can refer a whole section number 5 is devoted to this methodology, limit state method. It will start with clause number 35. You can refer IS 456 section 5, which will start with clause number 35. So now we have to understand what we were talking in the previous slide, that there are some limit states. So what are the type of limit states? First of all, we will say it is limit states of collapse. That means when structure will be approaching the collapse. Structure will not collapse, but it will approach the stage of collapsing. So you can refer clause number 35.2 again from IS 456. Now let us understand it more effectively. The limit state of collapse of the structure, either structure or any part of the structure, could be assessed from the rupture. So there may be, when you see some rupture in the structure or some component of the structure, then you will say now this structure is approaching the limit state of collapse. So now when you see rupture, then you will say the structure is approaching the limit state of collapse. Because if there is any rupturing in the structure component, that does not mean that structure has failed. So it can be assessed from rupture of one or more critical sections, and from buckling due to elastic or plastic instability. That means if there is any buckling, that means buckling just like bending, in case of any structural component of that structure, that means structure has not collapsed, structure is not getting failed, but it is just indicating. That means it will be the indication that later on it can collapse. So main focus is in this method is, that means we are not designing the structure for failure, but we are designing the structure by imposing some limits during design such that structure will never collapse, because we will be imposing limit. So that means when you will be seeing any type of behavior of the structure, then we will be saying that it is approaching the limit state of collapse. So here we have discussed number one, there may be any type of rupture, there may be second point any type of buckling, and third there may be any type of overturning. So This is limit state of collapse. It comes under the clause number 35.2. So what we have to do in the case of limit state of collapse, the resistance to bending, shear, torsion, because resistance to bending mean it will we are just relating it to buckling or we are relating it to rupture. Shear mean there may be some rupture, some cracks can observe. Torsion may result into overturning, so they are interrelated terms. So the resistance to bending, shear, torsion and axial load at every section shall not be less than the appropriate value at that section produced by probable most unfavorable combination of loads on the structure using the appropriate partial safety factor. So here we are terming it as partial safety factor. So limit state of collapse mean we will be designing a structure so that it can resist the bending, shear, torsion at any section due to any adverse type of combination of loads. So our structure will never fail because we are just treating it before any type of failure is possible. So then again, second type of limit state is basically limit state method. First of all, we have discussed limit state of collapse. Now limit state of serviceability, which you can refer it clause number 35.3. So it means when your structure is just constructed and it is ready for the use or ready for the occupancy, and when that structure is occupied, then what will be the behavior of the structure so that people should get occupy it safely. So here we have to understand the limit state of serviceability deal with discomfort to occupancy. That means if the occupants are feeling any discomfort, then we will say the structure has reached limit state of serviceability. And what type of discomfort? It may be caused by excessive deflection. That means there may be excessive deflection in the structure. Suppose there is a beam or there is a slab, it may get some deflection, but that deflection may be allowed. But if it is excessive deflection, then everyone who will be just looking about that structure, they will not be happy with the structure and they will feel discomfort, and their uh, confidence on the that component of that building will not be there. So they will not be able to utilize that structure effectively. So what type of discomfort? It may be due to excessive deflection. There may be excessive crack width. If you find some cracks in the any type of structure, if there may be a slab, then you will be trying to move away from the slab because it will your confidence will be losing. Any undesirable type of vibration, leakage, etc., or loss of durability. So that means this will be the limit state of serviceability when you feel any type of discomfort due to any type of regions. So that means when you are going to design a structure and you are taking care of limit state of serviceability, then first of all you have to be sure that there should not be excessive deflection, there should not be cracks of greater width, or you will be restricting particular width of the crack, or there should not be any type of vibration, leakage, as well as loss of durability. So all these parameters we were not getting uh, addressed in case of working stress method. So that's why it is the limit state of serviceability. Now we can understand here that structure has not collapsed, but providing discomfort to the occupants and failed to fulfill the intended purpose for which it is made up. Now, let us sum up it. The attainment of one or more ultimate limit states. So we have discussed two limit state of collapse or limit state of serviceability. So here, the attainment of any one of these states may be regarded as the inability to sustain any increase in load, whereas the serviceability limit states that it denotes the need for remedial action or some loss of utility. So that means if your structure which you have designed is reaching the limit state of collapse, that means now it is not able to sustain any type of load. After that, it will collapse. Whereas when we are talking about the serviceability limits, serviceability limit indicates that there are some remedial corrections need to be taken so that it should not lose its utility. Therefore, ultimate limit state or limit state of collapse are conditions to be avoided during the design, and serviceability limit states are the conditions that are undesirable. Therefore, in a limit state method of design, we are governing the safety of structure during and before its use by designing the structure such that to assure that we have to make it sure that the probability of reaching any limit state is acceptably low. That means when you are going to design by using limit state method, then we have to be assured that any type of limit state will never reach. So we have to design structure accordingly. We will be choosing the section, selecting the material, as well as applying various type of checks. That checks may be related to strength, that checks may be related to deflection, some crack width, or any type of leakage, durability, etc. So all these things we have to take care while designing any RCC structure with the limit state method.